another example of being able to find the arc length of a function, we have the function 1 plus 2x to the 3 halves, and it's going to go over the domain from 0 to 2. We can't use the distance formula to be able to get an exact answer for this because it's not aligned. Right? So first things first, let's graph this. All right, so we're going to go ahead, we're going to graph. I'm just going to use Wolfram Alpha. Not really. All right, and we're just going to go ahead and graph. I think it was 1 plus 2x to the 3 halves. Yep. So 1 plus 2x raised to the quantity 3 over 2. All right. And so this is what we get. And we could, of course, we could say over 0, 2 to get an even better description. All right, and it kind of looks like an e to the x almost, although not really what it's supposed to be. All right, so if we go through and try to plot this, okay, it said say to sketch the graph of this. So it looks like the graph is going to be a fairly basic sort of function. All right, in quadrant 1, so we get this sort of thing right here. All right, so and this is going to be where x equals 0, and this is where x equals 2. Right. Now we're going to use our function for arc length. Remember, arc length is the integral from a to b of the square root of 1 plus our derivative of our function square dx. And so we're going to take the derivative. The derivative of our function is going to be 2 times 3 halves x to the 1 half, or that's the same thing as 3 roots of x. And that's what we're going to substitute back in to our arc length formula. And this one actually works out really nicely. So the length is going to be the integral from 0 to 2 of the square root of 1 plus 3 roots of x squared dx. Now, when we square 3 roots of x, that just turns into 9x. So 0 to 2, square root 1 plus 9x dx. And now to evaluate this integral, we could just go ahead and use our substitution for this. All right, I'm going to turn this into the 1/2 power instead of the square root. And so u is going to be 1 plus 9x. du is going to be 9 dx's. And we don't want 9 dx, we just want 1 dx. So we're just going to divide both sides by 9. So du over 9 equals dx, right? And so our new integral in terms of u, integral from a to b, u to the 1/2 du ninths, all right? At this point, we can factor out the 1/9. We can take the antiderivative. So we're going to get 1/9 u to the 3 halves over 3 halves from a to b. Or another way to write this would be 2 over 27. All right, and what I did was I multiplied by the reciprocal. So that's going to be 1/9 times 2/3 since we're dividing by 3 halves. And then I'm going to back substitute 1 plus 9x back in for our u. And then our original limits of integration were from 0 to 2. All right, now be aware that when you substitute 0 in, it does not wipe out that second term. So we have to make sure that we plug it in. So we get 2/27, 1 plus 9 times 2 to the 3 halves, minus 2 over 27, and then that's going to be 1 plus 9 times 0 to the 3 halves power. All right. And now at this point, we're just going to do some house cleaning. We get 2/27, and then this is going to turn into 19 to the 3 halves. And I'm going to show you how to simplify that just a little bit more. Okay. And then in the other fraction, that's just going to turn into 1 for the 3 halves. Okay, or the other term, excuse me. So 2/27, 1 to the 3 halves. All right. Now, another way to write this, there's a lot of different ways to write this. We could split up 19 to the 3 halves into 19 to the first times 19 to the 1/2. Since when we add those together, that gives us 3 halves. And then this is just going to be our 2/27ths, because 1 times 1 to the 3/2 is 1. And then we know 2 times 19 is going to be 38. So we get 38/27ths. 19 to the 1/2 is the square root of 19 minus 2/27. And one final way to write this is if we factor out 2/27ths from both terms. So if we factor out 2/27, that's going to turn into 19√19 minus 1. All right. This is probably the answer that if you try to use some sort of computer algebra system or something like that, that they'll probably give you. All right. Now remember, if we go back to Wolfram Alpha, all right, what's really cool is it actually gives you the length of the curve. All right. So anytime you do a graph of a function, okay, if there is an exact answer, it'll give you that exact answer. All right. But of course, as I reiterate multiple times, during an examination, you're not going to have access to Wolfram Alpha. You're not going to have access to, you're going to have to go through and do it precisely this way. All right, showing all your steps. Okay. All right, so again, we're going to take a look at a few more examples in subsequent videos of being able to find arc length. And then what we'll do is we'll go ahead and start taking a look at average value.